Welcome to my channel for comprehensive tutorials on fundamental principles to complex problems. I'll cover it all. Feel free to share, subscribe for more contents. Thank you. Hello everyone. This is exercise 18 on page 200 if you have a textbook with you. And in case if you need a PDF of this book, you can definitely connect me on WhatsApp. The number is provided here. And basically, this is the third and the last exercise based on inequalities. And this exercise is focusing on linear programming. Now, in many occasions, especially when I was solving past papers, in there was a part in which inequalities are given and you are asked to find out the answers of it. Now, what happens is they ask you to find the unshaded region. Here, you will open some doors to find out why do we need to find out unwanted or unshaded area or unshaded region. Now, this is also called as linear programming, in which you are going to program your inequalities in such a way that you get the answers. Now, these are practical, real life questions based on linear programming. Let's see how we use linear programming in solving questions like this. Now, the most important part in this video is going to be your introduction to a website called www.desmos.com. In there, you will find a calculator, something like this, and there you'll be putting your inequalities. So my suggestion is that once you're watching this video, you can pause it, and in Chrome or whatever browser you're using, better go on www.desmos.com and in there click on calculator. In the calculator section, you will find these kind of spaces in where you are going to be putting your inequalities. Now, there is a trick to apply those inequalities in the calculator that I'll be guiding you throughout the exercise. Now, in here it says for question 1 to 3, draw an accurate graph to represent the inequality listed using shading to show the unwanted region. This is a very important and very crucial part in linear programming. This actually gives you a clear picture, or in a way clear answer to the question being asked. Okay, now it says there are three inequalities: x plus y less than or equal to 11, and y is greater than or equal to 3, and y is less than or equal to x. So there are three different inequalities for which you need to find the point having whole number, coordinate and satisfy these inequalities, which gives the maximum of x plus 4y and the minimum of 3x plus y. Now let's see how it comes. As soon as you open your desmos.com, you'll find spaces like this. In here, the trick is in your question, look at this carefully. In the question, it says x plus y is less than. This part, look at this carefully. X plus y is less than 11. I should mark this precisely like this one. This is saying less than or equal to, but when you go in Desmos, you will put opposite, greater than or equal to. Okay. Now, why we are doing so, I'll let you know soon. Now, the second part is saying y is greater than or equal to 3, but in Desmos, you will put less than or equal to 3. Third part is saying that y is less than or equal to x, but in Desmos, you will put opposite. Now, once you put these inequalities in your Desmos, you will find that the maximum value is 26 at 6,5. Now look at this. Why are we saying 6,5? Now go at 1, 2, 3, 4, 5, 6. This is 6 and this is 5 over here. This is the whole number you are getting, and this is the maximum point in this region. Now, when it was say unwanted, that means technically you should be shading up above this area should be shaded. But for solving this kind of question, we are doing opposite. This is why it's giving you the highest point. When it comes to the minimum value, 12 at 3, 3. Now, where is 3, 3? 3, 3 is here. This is 3 and 3. Now, the question arises from where we get this 26. Now, look at the equation given for finding out the maximum and the minimum value. In here, I am going to take this down below and see how do we get maximum and the minimum value, which is given in the question itself. This is going to be for minimum. Now, since we have found out the value of x and y, x is 6, for example, and y is 5. So this is going to be 6 plus 20. It's going to be 26. So 26 is the maximum value. When it comes to the minimum value, which is 3, 3, so that means 3x, x is a 3, and plus 3. That means 9 plus 3 is going to give you a 12, which is your required answer. Now, coming up to question number 2, which is saying that 3x plus 2y greater than 24, x plus y less than 12, and y is less than 0.5x, and y is greater than 1. Now, maximum value, as you know, in the previous question, it was 2x plus y, 3y, and the minimum value is x plus y. Putting these inequalities in the Desmos, you should know that I'm always telling you that to put the opposites of what you have got already in the question itself, put these values in the Desmos and see these are the lines that you get in the Desmos. Now, in here, what do we need to find out? Whole number coordinates and satisfy the inequalities, which gives 2x plus 3y, and minimum value is x plus y. Now in here, you can see that 8, 3 is the maximum point. 8, 3 lies over here. This is 8 and 1, 2 and 3 is going to be somewhere here. 8, 1, 2, 3. This is the highest point. And when it comes to the lowest or the minimum is 7, 2. 7, 2 is this one. 7, 2. 7 and 2 is over here. This is the minimum point and this is the maximum point. And we know very well that 8, 3 is the maximum and 7, 2 is the minimum value. Now bringing these two equations over here and getting the values done. Since we know that x, what we are getting is x is 8, 3. 8, 3 is the maximum point and 7, 2 is the minimum point. Now, when it comes to substituting the values, x is 8 plus 3 times 3, and in here x plus y, that means 7 plus 2. So this is going to give us 8 times 2 is 16. 16 plus 9 is going to give us a 25, and 7 plus 2 is going to be giving us a 9, which is the required answer. Okay, now moving on to question number 3, which is something like this. Exactly the same type of working is required. You need to open your Desmos, and using Desmos you will be putting these equations, inequalities in here. But remember that in the question itself it's giving you less than or equal to, but once you are putting in Desmos it's be greater than or equal to, opposite of whatever you have in the question. Now in here you can see the minimum point and the maximum point is given out of this, and in here the maximum point is 20, 0. That means 20 and 0. This point is the one which is the maximum point, and minimum is 14, 8. 14, 8 is somewhere over here. 14, 8 is this one. Now substituting these values, 20, 0 in the maximum, that means 20 times 2 times 20 and plus 0, that means going to be a 40 as a maximum. When it comes to minimum value, x value is 14. That means 14 times 8 is going to give us 112. So this is going to be your required answer. When it comes to question number 3, it's something tricky and bit difficult to understand. So where this question was 3 4. Okay, now it says Kojo is given 1.20 to buy some peaches and apple. Peaches cost 20 cents and apple cost 10 cents each. He is told to buy at least six individual fruits, but he must not buy more apples than peaches. So these are the conditions that we need to make inequalities. So let x be the number of peaches and the number of apples be y. So you need to write down three inequalities which must satisfy, and then draw a linear programming graph and use it to list the combination of fruits that are open to Kojo. Now, these are the constraints that we need to consider before starting this question. The price is zero point 0.2 and 0.10, or you can say 10 cents. Why we are writing 0.20? Because every cent is a hundred part of a pound. So in that case, 2 is divided by 100 is going to give you 0.20 and 0.10. Now, this is the constraint, and the price should not be more than 1.2. So these are the first constraint of the total cost. Get it? Now, when it comes to the minimum number of fruits, for minimum number of fruits, you should have 2 times x plus y is should be less than or equal to 12. Now, what we have done is we have divided everything, multiplied everything by 100. So we have got exchange with this equation. So these two are same equations. Okay, so mind it. Now, for minimum value is that the apple and peaches should not be more than 6. Okay, this is the second constraint. Then comes number of apple not more than peaches. That means y should not be equal. Y should not be greater than. It should be always less than x. Now, these are the three inequalities we come up with. The first one is that the prices about the prices, and this is about number of fruits and number of apples not more than peaches. So these are the three inequalities we come up. Now, putting these inequalities in the Desmos, you will get these three lines. Now, the coordinates that you have is the first is 3 3, which is over here. 3 3 is this one. 4 2 is this one. These are the whole numbers that you're getting. 4 3 is somewhere here. This is 4 3. 4 2 is down below. 4 2 is down below. 4 3 is this one. 4 4 4 4 is another one. These are the numbers 5 1. 5 is this and 1 is this. 5 1 is this one. Then comes 5 2. 5 2 is also a number that comes within this range. And then comes 6 0. So these are the 6 points that you have in the triangle. Now, these are the things that you'll be putting in your Desmos. Be very careful. You'll be using opposite of what you have given in the question. Now comes the values. These are the points that you are going to get in your Desmos, and this is the requirement of this question. So what you have done is you have written three inequalities and then drawing a linear programming graph and use it to list the combination of fruit that are open to Kojo. So this is the x values are all as you can see in the question itself. It says the number of x is peaches and these are apples. So these are number of peaches, all x, this value, this value, this value, and all the y's are apples, and all the x are uh, peaches. So be very careful. These are the combination that he can get for the price that he has. Now comes question number 5. In question number 5 it says Ula is told to buy some melons and orange. Melons are 50 cents each and oranges 25 cents each. And she has $2 to spend. She must not buy more than 2 melons and she must buy at least 4 oranges. She is also told to buy at least 6 fruits altogether. Now, X is melons and Y is oranges. Write down 4 inequalities which must satisfy the given conditions. So first of all, this is the price, always remember, and this is the price of melons and oranges, and the condition is given. So once we multiply by 100, so you're going to get 2x plus y less than or equal to 8. Now what happens is that once we clear out this, then comes second inequality, which is x should be less than or equal to 2, y should be greater than or equal to 4, and both the fruits should not be greater than 6. So these are the four inequalities. When it comes to putting these inequalities in the Desmos, I have already explained you how to put this in Desmos, and you will get all these values. All the x values are going to be, as you can see in the question, x value will be melons. So all x values will be melon, this one, and this one, this one, this one, and this one. These are all melons, and all the y values are oranges. So these are oranges. These are the choices she has for all the values of y are going to be oranges, and these are the combination of fruits she can buy with the given choice. Now, when we are moving to the next question, it is over here. It says a chef is going to make some fruit cakes and sponge cakes. He has plenty of all ingredients except for the flour and sugar. He has only 200 grams of flour and 1200 grams of sugar. A fruit cake uses 500 grams of flour and 100 grams of sugar. A sponge cake uses 200 grams of flour and 200 grams of sugar. He wishes to make more than 4 cakes altogether. Now, let the x number of fruit cakes be x and the sponge cakes be y. Now, you need to write down three inequalities which satisfy the given conditions. So, first constraint is the chef has 200 grams of flour. This is for sure. Now, the chef has 1200 grams of sugar. A fruit cake uses 500 grams of flour and 100 grams of sugar. A sponge cake uses 200 grams of flour and 200 grams of sugar. The chef wishes to make more than 4 cakes. So these are the inequalities we come up with. Flour constraint is 500 grams and 200 grams. It should be less than or equal to 200 grams altogether. Now, sponge cake and the sponge cake and the fruit cake should be when they are added should be more than 4. It cannot be less than 4. So now these are the three inequalities we come up with: first one, second one, and third one. Now be very careful once you are putting these inequalities in the Desmos. This sign that you see is less than or equal to, in Desmos you are going to be using an opposite one. Now this is the graph that you are going to get, because this is giving you, this one is less than 4. That's why you are going to get a dotted line. Okay, so it should be greater than. This is why. But the other two lines are greater than and less than, so these are going to be solid line. Now in here we have got all the possibilities. 3 2. Now where is 3 2? 1 2 3 and 2 is this one. This is the first one, and 2 3. 2 and 3. These are all the possibilities. 2 and 4. 2 and 4 is over here. So these are all the dots, these are which are going to be your possibilities. So now in here it says x is the fruit cakes. All the x are fruit cakes. These are all fruit cakes, and these are all sponge cakes. Sponge cakes. So these are all the possibilities which are giving you the answer in detail. Now moving on to the next question. It says in question number 7, Quinn has a spare time job spraying cars and vans. Vans takes 2 hours each, and car takes 1 hour each. He has 14 hours available per week. He has an agreement with one firm to do 2 of their vans every week. Apart from that, he has no fixed work. Now, Quinn permission to use his back garden contains the clause that he must do at least twice as many cars as Van. X should be number of vans and Y should be number of cars. Okay. Now, we need to write down three inequalities. Now, first of all, constraint. We should look at this constraint first. Spraying a van takes 2 hours and spraying a car takes 1 hour. So, Quinn has 14 hours available per week. Quinn has an agreement of spraying two vans every week. Quinn must spray at least twice as many cars as van. So, first one is going to be this one. First inequality, that is a time constraint. Then the agreement constraint is that x should be greater than 2 and at least twice as many cars as van. So uh, van should be y and x should be cars. These are the three inequalities you come up with. So once you are putting these inequalities in the Desmos, remember always that in the question it's saying less than or equal to, but when it comes to Desmos, you will be putting this way. And there is a solid reason behind it so that you get all the possibilities. These are all the possibilities within the triangle. So within the triangle, you will get 2, 4. That means where is 2? 2 and 4 is somewhere here. 1, 2, 3, 4. Yes, this is the first one. This is the first point. 2, 4. Then comes 2, 5, 2, 6. 2, 5 and 2, 6. And then comes 2, 7, 2, 8, 2, 9. All these are the possibilities of having the combination of cars and vans. So, as you know very well, cars are all X's, all the vans are X's, and all the cars will be Y. So, these are going to be cars, these are all cars, and these are all vans. So, all the X's are going to be cars, two cars, and four van. This is the first possibility. Second possibility is two cars and five vans. So these are all the possibilities that you get in the answer, or you can say all the points or the coordinates that you get within the triangle itself to give you the correct answer. Okay, next comes question number 8, which is over here. In question number 8, we are going to be working with a situation in where, okay, question number 8 is here. It says the manager of the football team has 100,000 to spend on buying new players. He can buy defenders for 6,000 each or forwards 8,000 each. There must be at least 6 of each sort. The cover for injury, he must buy at least 13 players altogether. Let X represent the number of defenders and Y the number of forwards. In what ways can he buy players? Number one question. Second is, if wages are 10,000 per week for each defender and 20,000 per week for each forward, what is the combination of player which he has the lowest wage bill? So we will first of all we go for constraint. What are the constraint? Total expenditure should not be more than 100,000. 6,000 for defenders and 8,000 for forwards. Now this is the first inequality you come up with. The second is there must be at least 6 defenders and 6 forwards. So 6 defenders and 6 forwards. This is a third inequality. And the total number of players must be at least 13. So x plus y should not be greater should be greater than or equal to 13. So these are the four inequalities. Once you put in Desmos something like this. Okay, so these are all the possibilities. First one, second one, it says 6, 7. 6 is here and 7 is here. X is 6 and Y is 7. All these are the possibilities he can have for choosing the team. Okay, so 1, 2, 3, 4, 5. 5 are the possibilities that he can choose from to have a combination of players. So this is how you need to do the calculations for the wages. And for the wages, it's 10,000 for the X values and 20 1000 for y. So let's see what x's are and y's are for. X's are for over here. In here it says that x represents the number of defenders. X are defenders. All x's are defenders. These are defenders and these are all forwards. So these are all the possible combination of players he can have. Now x's are all defenders. So these are all defenders and these are all forwards. Okay, now from the inequality, we need to find out the value of y. When we make the y subject to the formula, it gives you something like this. Now, substituting the value of x, which is 6, and x equals 13, since the equation is already given here in equality, for x equals 6, so that means 6 times this in place of here, we are using 6. Okay, and 8y is going to be, so the value of y is going to be less than or equal to 8. That means the possible outcomes are going to be 6 7 and 6 8, that you can see over here also. 6 7 and 6 8. Graphically we found the answer, so no need of much of calculation, but if calculations are required, all the calculations are given here. You can pause the video and substitute the value and see yourself how this is going to be working for you. So when you have 7 defenders and 6 forwards have the lowest wages, for example, this is the one which is giving you the lowest one. Any other possibility is going to give you more than 190,000, not less. So that means this is not going to be the possibility. This is not going to be the possibility. Why? Because he need to have the lowest bill also. So the lowest bill is going to be for 7 defenders and 6 forwards, which is going to cost 190,000. Moving on to the next question, which is question number 9. And in question number 9, it says, a tennis player, golfer, has 15 euros to spend on golf balls costing €1 each and tennis ball costing 60 cents each. He must buy at least 16 altogether, and he must buy more golf ball than tennis ball. What is the greatest number of balls he can buy? And after using them, he can sell golf balls at 10 cents each and tennis ball for 20 cents each. What is the maximum possible income for from the sale? Now, these are the three constraints or inequalities we come up with the given constraints. The first one is this one, second, and comes the third one. Now, when these constraints or inequalities are put into the graph, you can see that remember it is less than or equal to in here in the graph desmos.com. I should write this once again, desmos.com, and it's here less than or equal to. In the graph it's going to be greater than or equal to, and then second one and the third one. Now as you can see, maximum once you go for the x values, this is 10 and 7, 10 and 8 I can take. Now this is the point, 10 and 8. Now once we solve this, that means 10 plus 8, 10 plus 8 is going to give us 10 plus 8 is going to give us 18. So 18 is the maximum number of balls he can buy. Now x is 8, x is 10 and y is 8. X equals 10 and y equals 8. Now comes second part of the question. It says after using them he can sell golf ball for 10 cents and tennis ball for 20. Now 10 cents means 0.1 and x value is 10 plus 0.2, 0.2 times 8. So once we multiply this, we are going to get this as 1.1. Let's see. It's going to give us 1, and this is going to give us 1.6. When we add them together, we get 2.6, or 2 euros and 60 cents. Once we are talking in terms of currency, we'll be using 2.60, which is the given answer in the book. Moving on to the next question, which is question number 10. It says a travel agent has to fly 10,000 people and 35,000 kg of baggage from Hong Kong to Shanghai. Two types of aircrafts are available: A, which takes 100 people and 2,000 kilograms of baggage, and B, which takes 60 people and 3,000 kilograms of baggage. He can use no more than 16 aircrafts. Write down three inequalities which must satisfy if he uses x of A and y of B. What is the smallest number of aircraft he can use? So we go step by step. The first step is to put all these inequalities in order. So first inequality is total aircraft constraint, which is x plus y should be equal to or less than 16. So even if it is equals to, it's going to be fine. So first inequality. Second comes passenger constraint. That 100 passengers and 60. First one is taking 110 passengers. First one is taking 100 passengers, and the second aircraft is taking 60 passengers. So passenger constraint is over here. Now baggage constraint. First plane is taking 2,000 and second plane is taking 3,000. And altogether it should not be greater than or equal to 35,000. Now simplifying these constraints, we come up with something like this. So x plus y less than or equal to 16 is going to be same. But when it comes to 100x plus 60y greater than or equal to 1000, once it's divided by 20, you are going to get this inequality. When the third one is divided by 1000, it's going to get 2x plus 3y greater than or equal to 35. So these are the three inequalities that we are going to put directly into the Desmos. And we can see over here, once we put these two inequalities in Desmos, you're going to get something like this. So x is giving you a 1, x is giving you 1 from here, and 15 from here. That means type A should be one plane, and for the second one, 15 planes. So 1 plus 15 is going to giving you a 16. So that means 1 and 15 is your going to be answer. 1 and 15 is going to be your answer. That means answer for the first question is going to be 16 aircrafts. So you can write over here 16 aircraft. That means uh, one for the A type and for B type 15. These are the two types of airplanes and the number of aircrafts. Second is, if the hire charges for each aircraft A is 10,000 for each aircraft, B is 120, 12,000. Find the cheapest option available for him. Now, since we have found out 115, so we are going to put these inequalities into consideration. And here we can see that we have these two. So this one is once we put these two inequalities in Desmos, we come up with 5 and 8.33. So x is 5 and y is 8.33. Now once we put this into the calculation, in here the cheaper option is A is 10,000 and B is 12,000. So once we put 5 and 8.3 over here, we are going to get this value, and when we multiply this we get 99.960. So this is going to be the cheapest option. Now comes part C of this question. It says cheaper option with A aircraft is 10,000 and B aircraft is 20,000. So which is going to be the cheapest option? We go for 13 and 3. You can see 11, 12 and 13 and 3. This is also the point. Once we put into the calculation, you're going to get this is the cheapest option available out of all three options: first, second, and third. So these are the options. Okay. Now, once we do the calculation mathematically, as you can see, these graphs are in this way. You can pause the video and see how these inequalities are put in Desmos, and we found out the answer. Now, when it comes to do the mathematical calculations, it is done in this way. Intersection of these two equation is going to give you the value of 115 is already found out. These two are going to give you first value and the second value. These are the 3 points where these three inequalities are touching each other. Then comes this calculation out of this one, this one. This is the answer or the cheapest option available, 5 and 8.33. When it comes to part C, this is the option that we have gone for, because this is going to give you the smallest value. Now, moving on to the next question. Okay, a farmer has to transport 20 people and 32 sheep to a market. He can use either Fiat, which is X, which takes two people and one sheep, and Rolls Royce, which takes two people and four sheep. So he must not use more than 15 cars altogether. What is the lowest number of cars he should use? Now let's see. If we see the constraints that we have, total number of cars constraint is this one, and people constraint in the first car is getting two, second car also two, but when it comes to sheep constraint, it's only one for the first one, Fiat, and four in the Rolls Royce, and the constraint are these three. When we put this into the Desmos, we come up with something like this. Now, once these two constraints are kept in Desmos, we are going to get this point, which is 2.67, and 7.33. So this is the point, which is x is equals to 2.67 and y equals 7.33. So altogether, uh, if I make it something like this in here, if I keep this 7 Rolls Royce and 3 Fiat, so it's going to be 7 plus 3 is going to give us 10 cars. Okay, now once we put these values into, now look at this one. Mathematically, when we are doing, we are taking these two equations, x plus y equals 10 and x plus 4y equals 32. So in here, we are going to get the value as y value is 7.33 and x value is 2.67. So now in here, the cheapest option available is going to be 2.67 and 7.33. So this option is the best option he should go for. This one is also done, but this is not the required answer that we are looking for. So the cheapest solution is this one. Next comes a total number of cars should be 10, and cheapest option available is this one at 2.67 and 7.33, which is costing this. So this is going to be your final answer. Now, when it comes to costing, if it is uh, 10, 3 plus 37. So now this is going to give us 30, and this is going to give us 210, which is going to give us 240, which is the price cheapest solution we are looking for. Moving on to the next question, which is question number 12. Okay, this one also, I'm not going to read to prolong the video. I'm going straight because this question you can see in your textbook also. These are the constraints that we have, and we made the inequality based on the question. Now, when it comes to the profit, it says 0.4 for the first one. And so you look at this, we have to consider this one. The profit function is already given that 0 0.4 of X type of books, and the notebooks are going to be only one. So these are the four constraints we come up with. We are putting directly in the Desmos, and we can see that we have 6 and 12 is the answer. 6 of A type and 12 of the other type. Once we are putting this into 0.8 of X is 6 plus Y is 12. So it's going to give us 4.8 plus 12. So it's going to give us 16, 17 we can say. Now, once B and C is also solved. For the second option, once we go for this one, these two inequalities are going to be used, and 10 10 is going to be the option. And once we go for the calculation of the third part, 80 cents on each type of A and 1 cent of this one. 1 pound, 1 pound for this. Sorry, it's a dollar. $1 and 80 cents for each type. So once we put all these calculations in here, so for the last one saying 80 cents, that means 0.8, and of 10 type plus 1 multiplied by 10, it's going to give us 8 plus 10, which is going to give us 18. 18 as the answer. Here comes question number 13. In here, I'm not going to read the question, but if you read this question in your textbook, or read by yourself, you will come up with these inequalities. These are the constraints that x plus y less than or equals to 25. He has 1600 to spend. That means 50 of x and 80 of y should be less than or equal to 1600. And he must have at least 9 of each type. That means x and y should be greater than or equal to 9, both of them. So these are the four inequalities. I'm putting straight into the Desmos graphing calculator. In here, I came to know that this is the point where these two lines are meeting, which is 13.3 and 11.6. So it is going to be this point, and once we put this into the profit condition, 50 of first kind and 60 of another, that means it's going to be, these 2 points are x and this one is a y. Once you're putting in the calculation, it's going to give us this much of profit, which is the required answer of the asked question. This is question number 14, in which the question is in front of you. You can have a look in your textbook. I am not going to read this. It has two parts of the question. In the first one says that the parking charges is $1 for a car and $5 for a lorry. Find how many vehicles of each kind he should admit to maximize his income. Second is if the charges are changed to $2 for a car and $3 for a lorry, find how many of each kind would be advised to admit. Constraints depending upon the questions are here. Three constraints: 10 of X types and 30 of Y types should be not less than or equal to, uh, should be less than or equal to 300, and both the lorries and the cars should not be uh, greater than, or I mean should say less than or equal to 20. 20 is the maximum, and x should be greater than always y. Now these are the constraints when we come up on Desmos. For the first one, 7.5 x and 7.5 y is the point where these two are meeting, and once we put into the calculations, we are going to get both are, this is a mathematical calculations, and this one is the graphical one. This one is mathematical, and the graphical is in front of you. Now once we do the calculations for the first one, we can see it is saying that profit is income equals 2x plus 3y. That means 2 times x value is 7.5 plus 3 times y also 7.5. So this is going to give us a 15, and 7.5 times 3 is going to give us 22.5, and once we add it with 15, it's going to give us 37.5. $37.5 is the answer. Now once we go for the second part of this question, these are the two inequalities that you should put in what you call Desmos, and this is the profit or income formula that is given in the question itself, and the intersection point of these two inequalities is 15, 5, and x is 15, x equals 15, and y equals 5. Substituting this into the given equation, plus 3y, x is 15, and y is 5, so this gives us a 30, and 3 times 5 is a 15, so 45 is your required answer. That's all for this exercise. Very soon I am going to put a video on the next part of it, where all the difficult questions or kind of a testing is given on the next page of the same textbook. Next video is going to be on that. There are two more videos I'll be making, because there are two things that are going to be explained in different ways. So I'll be solving all of them. Keep watching, do share and subscribe to this channel, so that I can provide you with a more authentic and all complete answers and solution for each question. Thank you very much once again.